We're now going to be talking about floodfill. Floodfill is a classic problem in computer science, which gives you a very good introduction to a new concept we're going to be talking about, which is backtracking. Now, what floodfill does, if I take this code over here, click on this code, put it inside a file, and let's run it. Floodfill essentially is this idea that we take a maze, so let me make this a maze. So I'll add in some obstacles. So I take a maze and I take a starting location, and I essentially want to see, given a certain algorithm, how can I walk through this maze? So I'm going to shift click, which will make it start right in this cell. And essentially, what it is showing us is the depth at which it reached this specific cell. So the algorithm that we wrote first reached here, then it kept going up. So actually, if I want to see the depth, that means that like one step away it got here, one step away it got here. This was 2 steps away, this was 2 steps away. If I want to see the order in which it reached it, I type in O, and it basically said that it first went from here, to here, to here, then here, down, so on and so forth. So this is the basic idea, just to give you a rough sketch of what we're about to look at. So now, if I look at the actual code, what floodfill does is it takes a grid and basically, given a starting row and call, walks through the grid, not going into walls and also not going off. So, for instance, floodfill takes in a row, a call, and a depth. And essentially what it's saying is, okay, if this row and call is not a wall, and if it hasn't been visited yet, then basically mark myself as being here, and then call floodfill in all 4 directions from where I am. So first, the different, I guess, what you would call base cases is if we reach some certain end conditions, like when do we stop going down this path? Now, if it's off the board, then we just return and do nothing. Then we take the cell and we see, okay, it's not off the board, but if it's a wall, then we return and do nothing. And if the depth is greater than or equal to 0, because in this representation, if the depth is -1, that means it hasn't been visited. So if it's 0 or greater, that means it's already been visited, so we don't want to revisit it. So then we essentially just return. Now, if all of these different cases don't hold, that means that we're now at a new cell, which means that we now basically want to fill in this cell with the current depth. So we do cell.depth equals depth. We fill in essentially what order we reached it in. And then we essentially now say, okay, I've gotten to this place. Now call floodfill on every single direction away from me. Now this is going to call floodfill on row -1, which essentially is going down, or is going up. Remember, up is down. So this is going to try and floodfill from the cell above it. Row +1 is going to try and floodfill from the cell below it. This will try and floodfill from the cell to the left, and this is going to floodfill from the cell to the right. And notice how every time we make the recursive call, we increase our depth +1, because then we're essentially moving 1 away from where we were before. Now, if we go back to this example, let's say that I put everything like this. So the key thing that you need to always identify with floodfill is what is the order in which we're going to the cells around us. Because here, we're first going into the up direction, and then the floodfill, when we make that recursive call, is just going to keep going in that path. And then once this path terminates, it'll finally get back to here. So first it's going to check up always, then it's going to check down, then it'll check left, then it'll check right. So in this example, if I call floodfill here, and remember this one's going up, down, left, right. If I call floodfill right here, it'll first put a 0 here, then it'll check up, so it'll put a 1 here. Now here is also going to call floodfill. It'll try going up, but that's off the board. It'll try going down, but we've already visited that. Then it'll try going left. It can go left, so it'll put a 2 here. It'll try going up. It can't go up because we are off the board. It'll try going down, so then it'll put a 3 here. This will try going up and then try going down. So then it'll put a 4 here. Then this will try going up. It can't because we're already visited. We try going down. We can't because it's a wall. We try going to the left. We can't because it's a wall. So then we try going right and we can. Then in this situation, we try going up. We can't because we visited that place. That's where we started. We try going down. It's a wall. Left, already visited. Right, it's a wall. And so then we basically say, okay, we tried all of these cases, so none of them worked out, so let's just return. So then it returns. This also has no place to go. It keeps going backwards until it gets to the beginning. And notice how the beginning also has no direction it can go in, so it's done. So if I click Shift here, just as we expected, it walked 0, 2, 3, 4, 5. So what I would recommend is that you change around the order in which these directions are called, and then see if you can still trace out what the flood fill is going to look like. This is a great way to basically make sure that you understand the algorithm, and it's also pretty simple.